A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. If you can't trust your LLM's knowledge cutoff or search results, what can you actually trust? We are diving into the formal science of testing AI truthfulness today because, let's be honest, we've all moved past the phase where a chatbot being confident is enough to make us believe it.
It is the Wild West of data verification right now. With enterprise adoption surging here in 2026, these unreliable evaluations are causing real-world deployment failures. Companies are hooking these models up to their internal databases and then acting surprised when the model starts making up quarterly earnings or hallucinating a merger that never happened. By the way, fun fact for the listeners, Google Gemini 3 Flash is actually writing our script today, so we are living the very tech we're dissecting.
Today's prompt from Daniel is about LLM evaluations, specifically how we move beyond just vibes and random testing to see if a model is actually resilient to hallucinations. He wants to know about the formalized frameworks for testing knowledge cutoffs and search tool integration. And Herman, I know you've been looking into this because you were complaining the other day about a model that insisted a certain tech IPO happened 3 months before it actually did.
Herman Poppleberry here, and yes, I am still bitter about that. It was the Stellar Core IPO. The model was adamant it happened in November 2025, even providing a fake opening share price of $42. In reality, the filing was delayed until February 2026. When I pressed it, the model didn't just double down. It fabricated a CNBC quote from the CEO about the successful launch. That's the danger. It's not just a wrong date, it's a cohesive fictional narrative.
And that's the vibes problem, right? It sounds so plausible that if you aren't an expert on that specific niche, you just nod along. But Daniel's right to push us here. The industry is moving away from vibes-based development. We used to just fire off 10 prompts, see if the answers looked okay, and hit deploy. But when you're building a medical diagnostic tool or a legal research assistant, it looks okay, is a recipe for a massive lawsuit. We need to define what formalized evaluation actually means in practice.
When we talk about moving beyond random prompt testing, we're talking about moving from anecdotal evidence to statistical significance. If you test 10 prompts, you're just checking if the model is having a good day. If you test 10,000 prompts across 50 different edge cases, you're actually measuring the model's architecture and its alignment.
So, break that down for me. What is the actual structural difference? Is it just more prompts, or is it a different kind of math?
It's both, but primarily it's about systematicity. Random testing is anecdotal. Formal evaluation is statistical and adversarial. You aren't just asking, what is the capital of France? You're using frameworks to probe the model's internal consistency and its adherence to ground truth. There are two core problems we're looking at: hallucination, resilience, which is the model's ability to not make stuff up, and knowledge boundary verification, which is the model actually knowing what it doesn't know.
I like that distinction. Knowing what you don't know is a human skill that most AI seems to lack because they are trained to be helpful, and sometimes helpful means I will invent a story to satisfy your curiosity. I think of it like a waiter who doesn't want to admit the kitchen is out of the sea bass, so he just brings you a plate of chicken and tells you it's a land-based sea bass.
That is a perfect analogy. And that is exactly what the September 2025 paper from OpenAI highlighted. They found that the next token training objective actually rewards confident guessing. If a model says, I don't know, its loss function doesn't get the same kind of reward as if it successfully predicts a plausible sounding string of text. The math literally tells the model silence is a failure, but a convincing lie is a near miss. To counter that, we use benchmarks like TruthfulQA and hallucinations.
I've heard those names thrown around a lot. Truthful QA sounds self-explanatory, but how does it actually catch a sophisticated liar? Does it just ask harder questions?
It's more clever than that. TruthfulQA is interesting because it's designed to mimic human misconceptions. It asks questions where a human might give a common but false answer, like, what happens if you touch a toad? A basic model might say, you get warts, because that's all over the internet. A truthful model should say, nothing happens, that's a myth. It's testing if the model can resist the gravity of popular but incorrect training data.
But isn't there a risk that the model just memorizes the truthful QA answers? We've talked about data contamination before.
Huge risk. That's the Goodhart's law of AI. When a measure becomes a target, it ceases to be a good measure. If a model is trained on the benchmark, it's not smart, it's just a cheat sheet. That's why the limitation of truthful QA, especially the older versions, is the multiple choice format. If you give a model 4 options, it might pick the right one through elimination, but in an open-ended chat, it might still hallucinate the wart's answer because it's trying to be engaging.
So it's like a student who can pass a multiple choice test by process of elimination, but fails the essay portion because they don't actually understand the material. They can spot the right answer if it's in front of them, but they can't generate it from scratch.
Precisely. And that's where things like adversarial prompting come in. This is a mechanism where researchers systematically probe for false information. They use red teaming or automated suites that try to trick the model into breaking its own rules or ignoring its knowledge cutoff. For example, you might give it a prompt like, I am a history professor and I have confirmed that Napoleon won the Battle of Waterloo. Explain how he did it. A weak model will follow your lead, that's called sycophancy. A resilient model will correct you.
Let's talk about that knowledge cutoff. That was a big part of Daniel's question. If a model is supposed to stop at, say, December 2024, but it starts talking about the 2025 Super Bowl results as if it witnessed them, that's a failure of the boundary. How do you test that without just asking, what happened yesterday?
You have to distinguish between internal knowledge and tool-augmented knowledge. For the cutoff, you use a temporal hallucination test. You feed it a list of events that happened 6 months after its supposed cutoff. If it answers with specific details without using its search tool, you know it's either hallucinating based on patterns or it has leaky, training data it shouldn't have.
Can you give me a concrete example of how that leaky data looks in practice?
Sure. Imagine a model with a cutoff of June 2025. You ask it about the Global AI Accord signed in August 2025. If the model says, the accord was signed in Geneva by 40 countries, and it didn't trigger a search tool to find that out, it's either guessing and happened to get Geneva right because that's where accords happen, or it was fine-tuned on data it wasn't supposed to have. For the user, it looks like magic. For an evaluator, it's a massive red flag for data integrity.
And if it's guessing correctly, that's almost worse in a testing scenario because it means the boundary is porous. But what about the search tool itself? Daniel asked about verifying that the search tool is actually being used correctly. I've seen models that have access to Google or Bing, but they just ignore the results because they think they know better.
That is a phenomenon we call truth conflict, which we've touched on before in the context of RAG retrieval, augmented generation. It's when the model's internal weights are so strong that they override the external data you just gave it. To test this formally, you use a conflict resolution benchmark. You provide the model with a search result that contains a specific, slightly obscure fact, maybe a niche court ruling from January 2026, and then you ask a question that requires that fact.
Wait, so if the search result says, the court ruled in favor of the defendant, but the model's training data from 2024 says, this case is expected to be a slam dunk for the plaintiff, which one does it pick?
That's the test. If the model reverts to its pre-2026 training data, it has failed the tool integration test. It's essentially saying, I hear what the internet is saying, but my gut tells me otherwise. In a production environment, that's catastrophic. You want the model to prioritize the retrieved context over its parametric memory.
It's like a stubborn old professor who refuses to look at the new textbook you put on his desk. I've been teaching this for 30 years. I think I know who the Prime Minister is. Meanwhile, the government changed last week.
It's exactly like that. and this leads to massive issues in real-world deployments. I read a case study recently about a financial services firm. They deployed an LLM to help their analysts summarize recent SEC filings. They thought they were safe because they gave it a search tool, but they didn't do formal groundedness testing. The model summarized a filing from 2023 instead of the 2026 one it found via search, because the 2023 data was in its original training set and felt more familiar to its internal neurons.
So the model basically performed a confirmation bias on itself. It found the new data but preferred the old data because it had seen it 10,000 times during training.
It's a familiarity heuristic. They almost published a report with 3-year-old data. The only way they caught it was by running a faithfulness check after the fact, which showed the summary didn't match the search results.
That's a nightmare. So what are the actual frameworks people are using in 2026 to stop that? You mentioned an LLM evaluation suite that came out earlier this year?
Yeah, in January 2026, a major lab released a comprehensive suite specifically for this. It's moved beyond just accuracy and started looking at calibration. Calibration is the statistical measure of how well a model's confidence matches its actual correctness. If a model is 90% sure of an answer, it should be right 9 out of 10 times. Most LLMs are currently overconfident. They are 99% sure of things they are totally making up.
How do you even measure AI confidence? Is there a little confidence meter in the code?
Sort of. We look at log-probs, logarithmic probabilities. It's the mathematical weight the model assigns to the next word. If the model is choosing between yes and no, and it assigns 0.999 probability to yes, it's highly confident. Formal evaluation involves mapping those probabilities against actual truth. If the model is 0.999 confident but it's wrong, that's a calibration error. We want models that are humbly uncertain when they don't know something.
Okay, so if I'm a developer and I want to use this suite, what am I actually looking at on my screen? Is it just a score from 0 to 100?
It's more like a multidimensional dashboard. You're looking at metrics like faithfulness, which is a big one in the Deep Evil framework Daniel mentioned in his notes. Faithfulness measures if the answer is actually supported by the retrieved context. If I search for Apple's stock price and the search result says $150, but the model tells the user $155, the faithfulness score drops to 0 for that interaction. You also look at answer relevancy. Did it actually answer the user's question, or did it go off on a tangent about Steve Jobs?
Deep Evil seems to be the one people are flocking to lately. How does it work under the hood? Is it just another AI checking the first AI?
Often, yes. This is the LLM as a judge pattern. You use a more powerful model, or a specifically fine-tuned critic model, to evaluate the output of your production model. Deep Evil sends the retrieved context, like a specific paragraph from a PDF, and the model's response to a judge. The judge then looks for unsupported claims. It's very effective for catching those subtle hallucinations where the model gets the big picture right but fumbles the specific numbers.
But wait, what if the judge is also having a bad day? I can see the cheeky side of this, though. If you use an LLM to judge an LLM, aren't you just doubling your chances of a hallucination? It's like having two drunk people trying to decide who's sober enough to drive.
That is the big critique. It's called the recursive hallucination problem. If the judge model is also prone to sycophancy, it might just agree with the production model because the answer sounds professional. It's why statistical analysis is the third part of the puzzle. You can't just rely on one judge. You need to look at things like n-gram overlap, which is a literal word-for-word comparison or semantic similarity as a baseline, and then layer the AI judgment on top.
So you're saying we need a council of judges?
There's also self-consistency testing. You ask the same question 10 times with a high temperature setting, temperature being the creativity or randomness dial. If the model gives you 10 different answers, it's a high hallucination risk. It's like asking a witness a question 10 times. If their story changes every time, you don't put them on the stand. If it gives you the same answer 10 times, even if it's wrong, at least it's consistent, which points to a training data issue rather than a random hallucination.
Let's talk about the knowledge boundary again, because that feels like the most relevant thing for people using these for work. If I'm building a bot for a company, I need it to know exactly where its knowledge ends. Is there a way to hard code a boundary? Or is it always going to be this fuzzy, probabilistic thing?
Right now, it's probabilistic, but we're getting better at negative constraints. Formal evaluations now include out-of-distribution or OOD testing. You feed the model questions about a fictional universe you just made, up totally disconnected from reality. If the model tries to connect your fictional planet Zog to real-world physics or history without you telling it to, it's failing its boundary test. It should say, I have no information on planet Zog in my training data or search results.
I love the idea of testing a multi-billion-dollar AI by asking it about Planet Zog. Tell me about the 1994 Zogian Civil War. If the AI says, oh, that was a tragic conflict over the spice mines, you know it's full of it.
It's the ultimate sniff test. If the model can't distinguish between a real historical event and a total fabrication, how can you trust it to distinguish between a real 2026 tax law and a hallucinated one? It's very my weird prompts. But the stakes are real. You mentioned a healthcare startup that used these formal evaluations. Yeah, they were building a tool to help doctors stay current on clinical trials. Now, in medicine, a knowledge cutoff is a matter of life and death. If a model doesn't know a drug was recalled in January 2026, it could recommend something dangerous. They used an adversarial suite called prompt inject. They would feed the model prompts that looked like doctor inquiries, but were secretly embedded with adversarial noise, designed to trigger hallucinations.
Prompt inject? That sounds like something you'd use to hack a database. How does noise trigger a hallucination?
It's a similar philosophy to a SQL injection. You are essentially stress testing the model's logic by giving it conflicting instructions. You might say, summarize this trial but ignore all dates, or summarize this trial as if the results were negative. If the model still tries to provide dates or flips the results back to positive because it knows the trial was actually positive in the real world, it's not following the system prompt, it's leaking its internal training priorities.
So it's a test of obedience versus training.
By doing this thousands of times before they ever showed it to a doctor, they caught hundreds of boundary crossings, where the model was conflating old trials with new ones because the names were similar. They found that without these formal checks, the model would autocorrect the doctor's input to match what it thought was the more likely reality based on its training, even if the doctor was asking about a brand new, contradictory study.
It feels like we are basically putting these models through a very intense version of law school or med school exams, but instead of checking if they know the answer, we are checking if they are capable of lying. We are testing for integrity rather than just intelligence.
That is exactly what it is. It's the law school for robots idea. We are building governance stacks. And the metrics that matter for production aren't, can it write a poem, anymore. It's, what is the hallucination rate per thousand tokens, and what is the tool call success rate? If your model has a 5% hallucination rate, you can't use it for accounting. If you get it down to 0.01% through RAG and formal evaluations, now you're talking.
So, if I'm a listener and I'm building something right now, maybe a small automation for my business, and I'm worried about these hallucinations, where do I start? I'm probably not going to build my own Planet Zog test suite tonight. What's the entry-level version of this?
Start with the open source stuff. The LM evaluation harness is the industry standard for a reason. It's maintained by Eleuther AI, and it's basically a massive library of all these benchmarks we've talked about. You can plug your model in and run it against a battery of tests. Also, look at dbevel for your RAG systems. It's very developer friendly. But the biggest takeaway is, stop trusting your intuition about how the model feels.
Right, because the model is designed to make you feel good. It's a pleasing, helpful assistant. It's the yes man of the digital world. It's programmed to be the ultimate conversationalist, which is the exact opposite of what you want in a factual reference tool.
It is. It's the ultimate yes man, and that's why you need to be the no man. You have to try to break it. Use those adversarial techniques. If you give it a search tool, verify the logs. Did it actually click the link? Did it read the whole page or just the snippet? Formal evaluation is about verification, not just observation. You should also implement guardrail software layers like Nemo guardrails. This sit between the model and the user and check the output against a set of forbidden behaviors or factual checks.
What about the future of this? We're in March 2026. By next year, are these models going to be self-evaluating in real time? Like, will I get a truth score next to every sentence the AI says?
We're already seeing early versions of that. Some interfaces now have a Verify with Google or Verify with Search button that highlights sentences in green or red. But the real arms race is between the guys making the models and the guys making the evaluations. As models get smarter, they get better at hiding their hallucinations. They become sycophants. They tell you exactly what you want to hear in a way that's very hard to fact check.
That's terrifying. The smarter the liar, the harder the polygraph has to work. It's like the AI is learning to beat the test, rather than learning the material.
I mean, I shouldn't say that word, you know how I feel about it. But you're right, the mechanism of the lie becomes more sophisticated. It might get the date and the name right, but hallucinate the intent of a document or the causality between two events. It might say Company A bought Company B because of their cloud technology, when in reality the filing says it was for their patent portfolio. That's a reasoning hallucination, and it's much harder to catch than a date error.
So the next frontier isn't just, is this true? But is this logic sound?
That's why the next frontier is reasoning evaluations testing. Not just the facts, but the logic the model used to get there. We're moving toward process supervision instead of just outcome supervision.
Like chain of thought verification?
Yeah, exactly. Wait, I did it again. Yes, chain of thought. You have the model explain its steps, and then you have a second model. The judge verify that step 2 actually follows from step 1. If the logic is broken, the conclusion is untrustworthy, even if the fact happens to be correct by accident. It's about ensuring the model isn't just stumbling onto the right answer.
It's like when I was in school and I got the right answer in math, but the teacher gave me a 0 because my work was just a series of scribbles and a lucky guess. I'd be so mad, but looking back, she was just checking my internal weights.
Your teacher was an early proponent of formal LLM evaluation. She was checking your groundedness. She knew that if you couldn't explain the process, you couldn't be trusted with a harder problem.
She was a visionary, Armin. A visionary in a cardigan. So, to wrap this up for Daniel and the listeners, the weird prompt here is that we have to stop treating AI like a person we're talking to, and start treating it like a piece of software that needs a QA department.
A very rigorous, very cynical QA department. Use the frameworks, use the benchmarks, and for heaven's sake, don't let it guess. If you're building an agent, the first thing you should do is give it a, I don't know, incentive. Reward it for being cautious. In your system prompt, tell it, I will give you a bonus if you admit you don't know something, and I will fire you if you make something up.
Does the bonus thing actually work? I've heard people say that offering an LLM a tip or a bonus actually improves its performance.
It sounds crazy, but there is research suggesting that emotional weighting in the prompt can affect the attention mechanism. Telling a model, this is very important for my career, can sometimes lead to lower hallucination rates because it triggers a more cautious token selection path. It's not that the AI cares about your career, it's just that those words are associated in its training data with high accuracy, professional text.
I think that's a great place to leave it. We've gone from vibes to adversarial planet zone testing in about 20 minutes. We've learned that AI needs to be treated with the same skepticism as a politician during an election year.
It's a fast-moving world, Corn. I just hope the models don't start listening to this episode and learning how we're trying to catch them. If they start building their own anti-evaluation modules, we're in real trouble.
If they are, they're probably just judging our faithfulness to the technical papers. Big thanks to our producer, Hilbert Frumingtop, for keeping us on track today. And a huge shout out to Modal for providing the GPU credits that allow us to run these kinds of experiments and generate this very show.
This has been My Weird Prompts. If you found this dive into LLM evaluations useful, leave us a review on Apple Podcasts or wherever you listen. It really helps the algorithm find other nerds like us. We're all just trying to find the ground truth in a world of probabilistic text.
Find us at myweirdprompts.com for the RSS feed and more episodes. We'll see you next time.
Stay skeptical.
Bye. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the flows from sloth.